Okay. Yes. So, dear students, yes, today we are going to start, that is electric potential and also capacitors. Electric potential and capacitor will discuss, right? Okay. So let us see. This is one of the most important topic, and every year, so questions will get from capacitor as well as potential, right? So let us see the question asked in 2026. Okay. So let us see the question asked in so this one in this chapter electric potential. Let us see which of the following statements are correct. See, this inside a conductor, the electrostatic field is zero. Okay, yes. So inside the conductor, the electric field is zero. This is, let us see what you have to remember. So this one is C. So this is, so conductor, whenever you give the charge to the conductor, immediately the charge will reside on the surface. So it comes to the surface because it is a conductor. Okay, so once if it comes to the conductor, what is the electric field intensity inside the conductor? Electric field intensity inside the conductor becomes zero. As electric field intensity is zero, you must have to remember potential is constant. So that means what? Whatever the potential is there here, let us take what this is a charge q and radius r. Then what is the potential on the surface of the kq by r, or 1 by 4 pi epsilon naught q by r. This is the potential on the surface of charged conductor. Then what is the potential at the center? Potential at the center is not zero. Potential at the center is same as the surface. So therefore potential from center to the surface is same. So that's why the potential is same from center to the surface. If you draw the graph, if they ask, so this is the potential and this is the distance if they asked. Okay, this is about the distance. Potential is constant from center to the surface, and afterwards then potential is inversely proportional to distance. So this is what inversely proportional distance means. What it is? Hyperbola. We get rectangular hyperbola. So whenever they ask, this is 2026, they may ask what is the graph between potential to the, so this one is what distance. So potential is constant from center to the surface. That's why it is a constant. It's a straight line because same value up to the surface, and but it's not zero. But electric field intensity is zero, but potential is not zero. Okay, but afterwards, that from surface onwards, it is inversely proportional. That's why the graph is rectangular hyperbola. If you take the graph for electric field intensity, as electric field intensity is zero from center to the surface, as it is what center to the surface is zero, then it starts from, here to here is what inversely proportional. That's why hyperbola you get. If you take the graph between electric field intensity to distance, then the graph is, as the intensity is zero from center to the surface, afterwards it is, hyperbola you get. Okay, this one you have to remember. So based on this one, you have to remember electric field intensity inside the charged conductor is zero. Even we can say what spherical shell also. Even in the spherical shell, as it is what solid conducting sphere, even though solid conducting sphere, charge resides on the surface. So the same as even the spherical shell also the same thing we can say. Okay, even though it is a charged conductor, so that means what solid conducting sphere, charge resides on the surface. Same thing we get, either it is the spherical shell or charged conducting sphere. Also the solid conducting sphere also the same thing we get. Okay, so that's why this is the first one is what? So this is the correct. Okay, inside a conductor electric field is zero, it is right. And also we can say potential is constant from center to the surface. That you cannot take what zero. Right. Electric field at the surface of a charged conductor does not depend on the surface charge density. No, this is wrong. Electric field intensity is equal to sigma by epsilon naught. So it depends on surface charge density. That's why this is what wrong option. Okay. So A is correct, B is wrong. Then it depends on the surface charge density. Now, the interior of a charged conductor can have no excess charge in the static situation. Yes. So charge inside it is what not won't be there. That's why the C is the correct answer. And also we can say at the surface of a charged conductor, electrostatic field must be normal to the surface of every point. Yes, this is what, so perfect point. So correct one, because electric field intensity, okay, so it should be perpendicular to the surface. Okay, it should be the perpendicular. So electric field lines should be perpendicular to this one. So once if it is not a perpendicular, so it gives the, so this one is what? It gives, so along the tangent it gives, along the tangent of the surface it gives, once it gives the along the tangent of the surface, it gives what? Charges flow, then automatically we get the, so this current or some energies created, which is the violation of conservation of energy. That's why electric field intensity must be perpendicular to the, so this one surface of every point. It must be, so it is the correct one. Next, the electrostatic potential is zero everywhere inside the charged conductor. As I said, potential is not zero, but electric field intensity is zero. That's why E is the wrong statement. B and E are wrong. Therefore, the correct answer is A, C, and D. So this is the question asked in 2026. Okay, right. These points you have to remember, right? So these about electric potential. Then afterwards, what is the electric field intensity? Electric field intensity is KQ by outside. This one is what? KQ by R square. If it is the, this is the outside, but inside it is what? Zero, either spherical shell or solid conducting sphere. Okay. Right. If it is not a conducting sphere, so the non-conducting, the potential is, so not a constant, it is from center to surface, it varies. Right. So now let us take the another question. See, this is a thin spherical shell is charged by some surface. The potential difference between the 2 points C and P shown in the figure. So this one is potential difference. So this one is what? Same thing, spherical shell. As I told in the previously, it is a spherical shell. So in the spherical shell, potential at the center to surface is constant. As the potential is what? Same here and here is same. So then what we get? What is the potential difference between the points C and P? C is the same potential and also P is also the same potential. So as this is V, this is V, potential difference becomes what? Zero. Okay. So always we define for the potential difference by taking the, so infinity potential is zero, but potential we cannot, but potential difference always we have to say. Okay. Right. This one you have to remember same as the correct answer is zero. Okay. Right. Next, we go to the next question. So let us see. Two charged spherical conductors of radii R1 and R2 are connected by a wire. The ratio of surface charge densities of the sphere. Remember, this one is what? One is the radius R1 and another one is what? Radius R2. They are connected by a conductor. So once if they are connected by a conductor, one thing you have to remember, whenever two charged spheres are connected by a conductor, what happens? Charge flows from one sphere to the other till their not charges are same, till their potentials are same. Okay, so once if they are connected by a conductor, charges are not same. So always remember potential should be same. So that's why once if they are connected, their potential should be same, but not the charges. You must have to remember this point. So potential should be same. As the potentials are same, then so is asking V is equals to, this is what KQ by R, but is asking about the ratio of the surface charge densities is asking. V is equals to 1 by 4 pi epsilon naught, where K value, Q by R. Then we can take surface charge density is equal to charge per unit area, 4 pi r square. Wherever Q is there, sigma into 4 pi r square. If I substitute Q values here, then we get V is equal to 1 by 4 pi epsilon naught. Instead of Q, sigma into 4 pi r square by r. 4 pi cancel r. V is equal to sigma r by epsilon naught. Or sigma is equal to V epsilon naught by r. So we know that whenever two conductors are connected by a this one is what when two spheres are connected by a conductor, their potentials are constant. Any of epsilon naught is constant. Sigma is inversely proportional to r. As sigma 1 by sigma 2 is equals to what we can write? R2 by R1. That should be the correct answer. Okay, we cannot take what? It is inversely proportional. No, that's a R2 square by R1 square is wrong. Or R1 square by R2 square is wrong. It should be R2 by R1 is the correct answer. Okay, this you have to remember. So what is the important point here? When two spheres are connected by a conductor, instead of charges are same, you must have to remember potential should be same. Right. Now, let us go to the next question. Yes. Now, A, B, C are 3 points in a uniform electric field. The electric potential is. So let us take what? This is the electric field. Let us take, change the color. So this is electric field. So we know that in the direction of electric field, potential decreases. If I take one more point here, this is D, which is what? Same. So this one is what? On the same line of C. Then what happens this one? In the direction of electric field, potential decreases. So that's why what happened in the direction of electric field, potential decrease means what? A is. So less than VB. So I change the color. So let us take this one is VB. So this is what? More in the direction of electric field, potential decreases, VB. But so this is greater, but C and D should have what? Same line. That's why they have what? Same potential. So that's why VC should be equal to VD and should be greater than VA. So you must have to remember in the direction of electric field, potential decreases. So that's why what is the question is asking? The electric potential is maximum where? Maximum at B. Therefore, the correct answer is maximum at B is the correct answer. Okay. So this you have to remember, right? Right. Next, let us take next question. Right. So given below two statements, one is labeled as assertion and other is labeled as reason. So assertion, the potential at any axial point at 2 meter distance from the center of the dipole. So dipole moment vector P bar of magnitude is given. So this is electric potential we have for two formulae. That is, one is electric potential due to, so the point charge. Electric potential due to point charge is 1 by 4 pi epsilon naught Q by R we have. This is the electric potential due to point charge. That means V proportional to 1 by R we have due to point charge. Suppose if the dipole is given, so once the dipole is given, two equal and the opposite charges are separated certain distance, then we can take it is the dipole moment we can write it as what? Q into 2L. So then, so now from this center, so let us take what? At one particular point, this is what? Theta is the, so theta at a distance of, let us take what? R. This is L and this is R. What is the electric potential at certain distance? Now we have this is equals to 1 by 4 pi epsilon naught P cos theta by R square. This is the electric potential at a distance of R from the center of a dipole moment P. So this is electric potential. So one thing you have to remember, what is the electric potential? Okay, so let us take what? I'll change the color, C. So what is the electric potential on the axial line. Axial line means what? Theta becomes what? As this is what theta is 0, then electric potential on axial line should be equal to 1 by 4 pi epsilon naught P by R square we can. So then what is the electric potential on equatorial line? This is the axial line. Then what is the equatorial line? Equatorial line is as theta is 90, then cos 90 becomes what? 0. Therefore, electric potential on equatorial line is 0, but on the axial line it is 1 by 4 pi epsilon naught P by R square we get. Now, let us see in this question what they asked here. Then assertion, the potential at any axial point. Axial point means what is the formula? Axial point, the formula is 1 by 4 pi epsilon naught P by R square. That is 9 into 10 power 9. What about the dipole is given? 4 into 10 power minus 6. Okay, it is what? So it is not centimeter, it is coulomb into meter. Okay, then. So by, what about R square? What is the distance is given? 2 meters. That is what? 4. So we can take it as what? 4 cancel. 9 into 10 power 3. This is what? Volts. Yes. This is what? 9 into 10 power 3 volts. Yes. So this is assertion is correct. Then, because we got the potential on axial line. If they ask what potential on equatorial line, it is 0. Then, what is the electric potential at certain angle? Then that is the formula. Okay, then reason. V is equal to, this is 2p by 4 pi epsilon naught R square, where R is the distance of axial point situated to. What is the formula for potential on axial line? It is not 2p, it is 1 by 4 pi epsilon naught P by R square. That's why this reason is wrong, but assertion is correct. Okay, this point you have to remember. Next. So we go to the next question. Yes. Then what about the angle between electric lines of force and equipotential surface? So just now I gave, always remember the equipotential surface and electric field. Just now I gave, this is the electric field and this is the equipotential surface. Always they are perpendicular. You must have to remember, this is the standard point you have to remember. Angle between electric lines of force and also equipotential surface. The angle between electric field lines and also equipotential surface is 0. Then suppose whenever I ask, this is what equipotential surface V1, V2, where V1 is equal to V, V2 also equal to V. What is the work done? Work done means what we can write? So potential difference into charge that is moved. As the potentials are same, on equipotential surface, if any charged particle is moving from one point to the other, then work done becomes what? 0. Whenever from the equipotential surface are given, so if the charged particle is moving from one equipotential surface to another equipotential point, then equipotential points, if you are moving at any charged particle, the work done becomes what? 0. Okay, this point you have to, whenever you want to calculate the work done, just to calculate the potentials of those 2 points and charge that is moved. Okay, we see the type of questions also, this type of questions, let us see. Okay, right. Right. Next, we move on to the next question. Right. Now, let us take this question. 6 charges plus Q minus Q plus Q minus Q plus Q minus Q are fixed at the corners of a hexagon of side D. So, as shown in figure. Okay, hexagon. So, we can draw. This is hexagon. So charges are given plus Q minus Q plus Q minus Q. Okay, alternate charges are given. So plus Q minus Q plus Q minus Q plus Q and minus Q. Right. So at the corners of hexagon of side D. Okay, this side is D is given. Now, the work done in bringing a charge Q naught to the center of the hexagon from infinity. So this is what infinity. So you have to remember that the potential at infinity is 0. Then as potential at infinity is 0, the charge we have to move, Q naught charge should be moved from, so there to here. Just now I gave, if you want to calculate the potential work done, so what you have to do, just now I gave, so work done is equals to what we can write, potential difference from 1 to 2 if you are moving. So V2 minus V1 into charge that is moved. But what is the, this is what potential at the infinity at the first point is 0. Therefore, so potential at this point 2 into the charge Q. Then we have to, our Q naught is charge that is we are moving. Then what is the potential at this 2? Then potential, this is D means what? Every point is what? All are what? Equal triangles you will get. This everything is what? D you get. So all distance are D. Then what is the potential you get? So then this potential is, what is the potential here? Potential is equal to KQ by, what is this distance? D. But this is what? Plus. Due to positive charge, potential is positive. Due to negative charge, potential is negative. Again, due to positive charge, potential is positive. Again, negative. Again, positive. That means what? K by D is constant, but one is plus Q, minus Q, plus Q, minus Q. All gets cancelled. But what is the potential there? 0. That's why what is the work done? So in bringing the charge from infinity to the point at the center of the hexagon is 0 you get. Next, we move to the next question. Let us take this one. It is also the same. So two charges Q1 and Q2 are placed 30 centimeters apart as shown in figure. Let us see this question. So here, this is what point A and also this one is what point B. So two charges Q1 and Q2 are placed 30 centimeters. This is Q1 and this is what Q2. I'll change the color. Yes, this is Q1 and this one is what Q2. Yes, they are separated by 30 centimeters apart, as shown in figure. A third charge Q3 is moved. This charge Q3 is moved from along the arc of a circle of radius. So this one is 40 centimeters. From C to D. Just now I said, so whenever you are work done to calculate from where to where you are moving, then what we can write, work done is equal to potentials of those two, this one points into charge that you are moving. What is the charge that you are moving from C to D? The charge that you are moving from Q3 to, so that C to D is Q3. Then we have to calculate potential at this point and also potential at D. Then, so that is what potential at D and also potential at C into charge that is moved. That gives work done. Okay, right. Then what is the potential at C? Potential at C you can write K into. So this is the potential at C. So potential at C is equals to what we can, or even we can write it as what, another way also work done we can write, which is V into Q is nothing but energy, or we can write it as what? So this is about potential energy. So at D to potential energy at C also you can take. That is what difference of energies also you can take. What is the potential energy? So formula which is equal to K into Q1, Q2 by R. If two charges Q1, Q2 are separated by distance R, then potential energy we can write it as K Q1, Q2 by R. So we can take, so in this, let us take, change the color, right? So then what about the potential energy? So then we can write as what he is asking, what change in potential energy. So what is the change in potential energy means, what is the potential energy at the first one? At the first, that is what at C. What is the potential energy? How to calculate the potential energy? So between at this point from here also, that is equal to K into Q1, Q3 by, this is 40 centimeters. Okay. So of course 40 by 100. So afterward I take, this is what, so plus, even you can take what, even this, that is equal to K into Q2, Q3 by. So as this is 40, this is 30, what about the distance of this one? 50. Then this is 50 by 100 we can take. So it is in, so this centimeters we are converting. Then what is the potential energy at D? Potential energy at D means what here? So one is due to this one. Due to this one is what we can get Q1 into. Now charge moved from C to D. Therefore Q1, Q3. And at what distance? Once the charge is moved from C to D, what is the distance between Q1 and Q3? 40. So 40 by 100 plus. So even between these two, that is equals to K into Q2 into Q3 by, this is what 10 by 100 we get. So once if you take the difference of these two, then we can get, these two gets cancelled. Okay. So then we can take it as what potential energy. So the change in potential energy. So change in potential energy. So this one minus this one. As you are subtracting from this part to this part, these two gets cancelled. Then you have, so this is equals to what we can write here. This one gets cancelled. So you can take 10K Q2 Q3 by, so this is what 1. So minus what we can write, this is what 2 it comes to. So this is 2K Q2 Q3 we get. Okay, this is what minus. Then what you can get this one 8K Q2 Q3 we are getting. So where K is nothing but you can write 1 by 4 pi epsilon naught, which is Q2 into Q3 we get. Okay, so these about, so then now we can take it as what here. So this is the change in potential energy. So if you compare with this, change in potential energy is given in the question Q3 by 4 pi epsilon naught into K is given. So where K is, change in potential energy of the system is, so Q3, of course, K into Q3 into 4 pi. So what about this one? So as Q3 into 4 by, means Q3 by 4 pi epsilon naught means what? K is equal to what we get? 8K2. Therefore, if you compare, so you get 8Q2 we get. That should be the answer. So what you have to do in this work done, you can take it as what? Potential difference into charge that is moved or difference in potential energies. Next, let us take another question. So a bullet of mass 2 gram is having charge 2 microcoulomb. To what potential difference must be accelerated starting from rest to acquire a speed of 10 meter per second? It's a simple. So work done, so is equals to what we can write? Change in kinetic energy. Work done is equal to what we can write? Potential difference into charge, which is equals to half mv square. Then we can take, so what about the V is asking through what potential? V is asking, charge is given 2 into 10 power minus 6, half into mass is given 2 into 10 power minus 3. You must be careful about the units. You have to convert gram to this one and microcoulomb to kg, gram to kg and micro to minus 6. So V square, V is given as what? How much? 10 into 10. So that's all you get. So which is equal to, this one is 10 power minus 3. Okay, then so 2V is equal to 100 by 10 power minus 3, or 2V is equal to 10 power 5, or V is equal to 10 power 5 by 2, which should be equal to 0.5 into 10 to the power of 5, or we can take it as, so this one is, if you multiply, so this is what kilo is given. So once if it is what kilo, you get V is equals to what we get? 0.5 into 100 into 10 power 3, which should be equal to 50 into 10 power 3, which should be equal to 50 kilovolt. That should be the answer. Okay, work done is equals to half mv square. Right. Next, we go to the next question. Identical charge minus q are placed at each corners of cube of side B. Then electrostatic potential energy of the charge which is placed at the center of the cube is. Then again the same thing. You have to remember this is the cube. So once if it is what cube it is given, So you must have to take. So what about this one is what? Body diagonal is what? How much you get? Root 3a if the side is a. Then what about center to the each vertex is root 3a by 2 we get. What about this one is what? Side is given b. Therefore root 3b by 2. So this is what root 3b by 2 is the side of each. But we have what all our minus q is there. There are. So this one is what 8 we have. Therefore, we can take it as what v is equal to 1 by 4 pi epsilon naught. So q divided by, of course, this is what negative charge by. What about the distance from this one? Root 3b by 2 we have. So such that how many are there? So how many charges are there? 8 are there into 8. That's all. Then you will get the answer to this one. Okay. Next. This is what potential. So how many charges are there? That many we can. Now, let us take 27 drops of same size. This is a different. So charged at 220 volts each, they come and form a bigger drop. Calculate the potential of the bigger drop. So how do we get? We have some formulae. Suppose let us take what each potential is V. There are what N drops are there. Then what is the total potential? Total potential is equal to N power 2 by 3 into V we can. You have to remember. So then we can take it as what? N power 2 by 3 means what? 27 to the power of 2 by 3 into 220. Then you can write it as what? 3 cube 2 power 3 into 220. Then you can get 9 into 220. So then 18 plus 1, 1980 volts. Whenever this is what potential is given, N drops are given, but you have to take what N power 2 by 3. But instead of giving potential, suppose, so let us take what N drops are there. This is the standard you must have to remember. In N drops, each, so potential is V. So let us take what charge Q. First I take what charge, then, so radius R and also potential V. So let us take what capacity C, surface charge density sigma, and energy is U. Then are combined to form a big drop. Then what about the big drops? So then big drops, these points must have to remember. Then what about the big drops? What is the charge? Big drop charge is NQ. Big drop radius is N power 1 by 3. Big drop capacity is N power 1 by 3 into C. Surface charge density N power 1 by 3 into sigma. Potential N power 2 by 3. That only asked in that question. And also energy, so N to the power of 5 by 3 into U. These points you must have to remember. Okay, that's all. Right. Next one, let us take, so a short electric dipole. So this is the electric potential due to dipole at a point distant point C from the center of the dipole. Just now I gave, you can do this question. So 1 by 4 pi epsilon naught P cos theta by R square. So as the dipole is given, angle is given, you can calculate electric potential. Okay? Right. As I told already, just everything is given, you can calculate electric potential. If it is electric potential on the equatorial line, it becomes 0. Next, we go to the next question. Is in a region the potential is represented by. So then whenever this type of questions are given, potential 6x minus 8xy plus minus 8y plus 6yz. Then force is asking and charge is given 2 coulomb. Then at a point 1 comma 1 comma 1. How do we get force? Force is equal to E into Q. Okay, of course, this E into charge already is given 2 coulomb. You have to calculate force. Whenever electric field potential is given, so variable electric field intensity is nothing but E is equal to negative potential gradient, we can say. This is electric field intensity is equal to dV by dx. So that is what Ex we get. Even Ey we can take minus dV by dy. Ez is equal to minus dV by dz we can. So if you differentiate, so then we can get, so E is equal to, E bar is equal to Ex I cap plus Ey j cap plus Ez k cap. So we can calculate Ex like this. If you want to take what Ex, that is called minus of dV by dx, which is equal to minus of. If you differentiate, it's a partial differentiation with respect to x, that is 6 minus 8y. X differential, this is 0. Even there is no x, that is also 0. That should be equal to minus 6 minus 8y minus of 6 into. At what point is asking? 1 comma 1 comma 1. Therefore, x is 1, y is 1, z is 1. If I take what y is, so this 6 minus 8 into 1, which should be equal to 6 minus 8, which should minus 2. Minus of minus is what? Plus 2 we get. Therefore, E is equals to, we can take minus. So minus of minus is what? Plus we got. Ex is equal to 2. Or we can write as what? 2 I cap. Then what about Ey? Again, Ey is equal to minus of dV by dy. Then minus of, again here there is no y, therefore 0, minus 8x, y differentiation 0, minus 8 plus 6z we have. Then if I substitute minus 8x1 minus 8 plus 6 into 1, which should be equal to minus of minus 8 plus 6, which should be equal to 16 plus 6 is minus. So that is what plus 10 we get. Okay. Is that right now? Yes. So then what do you get in this? This is plus 10 j cap. Similar way, so z also we can take. Ez is equal to minus of dV by dz, which should be equal to, this is 0 because there is no z. This is also 0. This is also 0. 6y we get. So 6 into 1, so which should be equal to minus 6. Okay. This one is what? Minus 6 k cap. If you take, so magnitude is asking. Then what is the magnitude of this one? 4, 2 square. And this is what? 100 plus 36, which should be equal to 140. 140 I can write as what? 4 into, okay, 4 3s are 4 5s are. That is equal to 2 root 35. Therefore, electric field intensity is 2 root 35. So, but F is equal to E into Q. E is 2 root 35 into charge is 2, which should be equal to 4 root 35. That should be the answer. So, force is 4 into root 35. Next. We go to the next question. Yes. Now we come to capacitors. This is 2026 question. Okay. Let us see. So 5 capacitors of capacitors are given. These are 2026. So let us see how to do this question. Now, so these are the capacitor. Find the equivalent capacitor and charge on each capacitor. So this is 50. How these connected? Let us take. So these all the three are connected. All 1, 2, 3, 4 are connected in parallel. So what do you get? This becomes okay. I'll change the color. Yes, this is, so 10, 10, 10, 10. 4, 10 are connected in parallel means what? 10 by 4. If n capacitor, each capacitor C are connected in series, the effective capacity C by n, so which is equal to 2.5. This is 2.5 and also this is 2.5 and this is 50 volts. Okay. Then, so what is asking? Find equivalent capacitor. As these two are connected in parallel, 2.5 plus 2.5 is 5 microfarad. Therefore, equivalent capacity is 5. Then what is the charge on each capacitor? So as this is 50 volts, if this is 50 volts, this one is also 50 volts. Therefore, what about the charge on this one? Charge is equal to 50 into 2.5, which should be equal to 125. So, charge on this capacitor is 125 we have. Then what about the remaining potential is complete. This one is also 50 volts. Even this is 50 volts. This one is also 50. 50 into 2.5 is again 125. But all are connected in series. That's why each capacitor will have 125 microcoulomb. So each will have 125 microcoulomb, even including this also 125. Therefore, what is the correct answer? This one. So effective capacity is 5 microfarad, and each capacitor will have the charge of 125 microcoulomb on all capacitors. That's all. This is the question asked in 2026. Next, we go to the next question. Yes. So even this type of question, look at here, consider two uncharged capacitors of equal capacities. One is then, one of them is charged by 100 volts. Let us see. There is a one capacitor, 200 picofarad, connected to 100 volts. One of them is charged by, so yes, consider two uncharged capacitor of equal. Okay, one more is also 200. Yes, one is charged to 100 and supply and disconnected. Now this capacitor is connected to, this is connected and disconnected. After that, it is connected to this one. So in uncharged capacitor is connected. The amount of electrostatic energy lost. Whenever it is given, this is what standard one, whenever C1 capacitor is connected to potential, but C2 is uncharged, now after that, they are connected. So this one is what parallel. What about energy loss? So one standard formula we have, energy loss is equal to half C1 C2 by C1 plus C2 into V1 minus V2 whole square. From this easily we get, so energy lost. So energy lost is equals to half into 200 pico, that is minus 12, into 200 into 10 power minus 12 by 200 plus 200 is 400 into 10 power minus 12 into V is how much? 100, but another one is 0 uncharged. That's all. You get this one. So 200 to the, this is what 100, this is 50, then 50 into 1 by 10 power minus 12, and which should be equal to 10 to the power of 4. That is 50 into 10 power. So minus 8 you get. So which should be equal to 0.5 into 10 power minus 6 joules. That is the first option. Right. We go to the next question. Right. If two, this is what two parallel plates. If it is given like this, what you have to do, if the plates are asked, if two plates are connected this way. So first of all, if there is no dielectric, what is the capacity? Epsilon naught A by D. Whenever, so dielectric is kept completely, then capacity is K epsilon naught A by D. Suppose if two dielectrics are placed, one K1, one K2, then, so which should be equal to K1 plus K2 by 2. So into epsilon naught A by D. If dielectrics are placed, so this way it is what placed K1 and another one is K2, then equivalent K is equal to 2 K1 K2 by K1 plus K2 into epsilon naught A by D. That way we have to take. Even suppose if the dielectrics are given, so this way it is given, this is so T1 and thickness and dielectric is K1, this thickness T2, dielectric is K2, this T3, this is K3, and so on is given. Then capacity epsilon naught A, T1 by K1 plus T2 by K2 plus T3 by K3, and so on we get. So based on these are the things you must have to remember. First you come to this question. So what is given? So same thing. These are the capacitor. The plates of a parallel plate capacitor separated by distance d. The two slabs of different dielectrics K1, K2 and thickness. So this is K1 and this is K1. This is K2 is given and this is 3D by 3 and this one is D by 2 and the remaining is how much? This is total is D. Then if totally D minus 3D by 3 plus D by 2. If you solve this one, so you get this is 6, you get or 3D by 8 this is. Okay. So 3D by 8 plus D by 2, this is 3D by 8, LCM is 8, then this is 3D plus 4D, which should be equal to 7D. So D minus 7D by 8, which should be equal to D by 8. This should be D by 8, but dielectric constant is 1. So if you substitute here, we get epsilon naught A by, what is the thickness here? 3D by 8 by K1 and the D by 2 by K2, where K2 is equals to, we can write it as what? K1 by 1.25. And what about T3? T3 is what? D by 8, but dielectric constant is 1. Then if you solve this one, but is equals to what is given? The capacitor becomes 2 times the larger than the wear. So that which should be equal to 2 epsilon naught A by D. That's all. Just to substitute T1 is equals to 3D by 8. Okay, I'll write here. So this is equal to 2 epsilon naught A by D is equal to epsilon naught A by. So this is 3D by 8 by this is K1 plus D by 2 into K2. K2 is equal to K1 by 1.25. Okay, plus D by 8, but there is no dielectric, which is what? Air. That's all. So if you solve this one, so epsilon naught A by D cancel, then solve for K1, you get the answer. Okay, right. So one last question we discuss. Right. Now, if you take this one, if the dielectrics are placed in this way, so just two questions of this type we discuss. So this is K1, K2, K3 are connected. Just now I gave one thing, that is whenever they are connected like this, so this is what K1, K2, K3, if it is given, K1, K2 is given means what? K1 plus K2 by 2. If 3 are given, what we can take? So same as this way, I'll change. So this is equal to, as they are connected to K1 plus K2 by 2. Here 3 are connected means what we get? K1 plus K2 plus K3. Okay, by 3 we get, and this is what K4 we have. Then, so, but now I already gave, if two dielectrics are given, one is K1, another one is what? K2, if it is given, then 2 K1, K2 by K1 plus K2, that's all. So this is what one thing, this is what another one, they're connected in parallel. Therefore, what we can write? Or we can write as what? 2 by K is equal to 1 by K1 plus 1 by K2 also we can write either this or this. Now I can take it as what? 1 by K effective is equal, okay, I'll change the color. So 1 by K is equals to what we can write? Or 2 by K. This one is 2 by K is equal 1 by K1. K1 is K1 plus K2 plus K3 by 3 we have, plus what about the 1 by K2? So that is equal to 1 by we have K4. That's all. This should be the answer to this question. Like this we get. So 3 are connected in a series like this. So K1 plus K2 plus K3 by 3 and this is K4. Now both are connected in, so one above the other means what? Either 2 K1 K2 by K1 plus K2 or 2 by K is equal 1 by K1 plus 1 by K2. Okay, like that we get. So that's all. One last problem, same type, and we'll finish this session. Next. So look at here the same type as the previous. So then we can take it as, how do we get this one? Let us take what here, one above the other. What about the effective? 2K2, K3 by. So this one is what? K2 plus K3 we have this part. And this is what? K1. Now again K1 and 2, K2, K3, these two are connected in. So like this, this way side by side. Then K effective is equal to K1 plus K2 by 2. which is equal to 2K2 K3 by K2 plus K3 by 2, which should be equal to K1 by 2 plus K2 K3 by K2 plus K3 we get, which should be equal to K effective. So that's all. This K effective is equals to K1 by 2 plus K2 K3 by K2 plus K3, and C equivalent is equals to what we can write. C equivalent is equal to K effective K equivalent into epsilon naught A by D. Therefore, epsilon naught A by D into K equivalent. That's all. So this is the way we can do the questions. Okay. So just to practice these type of questions, so so this one is what if you get this type of questions only. Okay, so practice these capacitors and also potential. Okay, we'll take another important topics tomorrow. So all the best.